Hi everyone, let's take a look at number 15 on page 53. What must be true about a and b for the function f of x if the function is continuous at x equal to 1 but discontinuous at x equal to 2? Step 1, divide this into two different columns. And in the first column, we're going to talk about what happens when x is 1. And in the second column, we'll talk about what happens when x equals to 2. So again, notice how x equals to 1 means the function is going to be continuous. And when we think about continuity, there are three steps that you want to think about. So I'm just going to write this on the side for you as a refresher just in case. And we'll go straight to condition number 3. So if a function is continuous, that means f of a must be defined. It also means there's a limit of the function as x is approaching to a. It also means that f of a equals to the limit of f of x as x is approaching to a. So again, f of a must be defined. The limit must exist. And of course, the first conditions are equal. So back to the first column. I'm going to go straight to condition number 3, which means if I think about f of 1, this equals to the limit of the function as x is approaching to 1. And again, if I zoom in for you, here's the next step. F of 1 means I plug x to be 1 in the first piece of the piecewise function. So in this case, it's going to be a times 1 minus b divided by 1 minus 2. Now, on the right-hand side, if you think about the limit, you could talk about the left limit, the right limit, make them equal to see if there's a limit. But because we know it's going to be continuous, there must be a limit. And if you think about just the second piece of the piecewise function, this means f of x is going to be 3x. And I'll put that in brackets, just like that. Now, if you think about the first step in limits, you're going to plug it in. 3 times 1 is going to be 3. On the left-hand side, that's going to be a minus b divided by 1 minus 2, which is negative 1. So again, a minus b equals to, again, if I cross multiply, negative 1 times 3 is going to be negative 3. Now, notice what I'm doing here. I'm going to isolate for b. So if I bring negative 3 to the left, that's going to be a plus 3. And if I bring negative b to the right, that's going to be b. So at this moment, I am saying b equals to a plus 3. And we're going to come back to this. Now, in the second column, let's go back up to the top. X equal to 2 is where the function is going to be discontinuous. That simply means if I think about f of 2, and I think about the limit of the function as x is approaching to 2, because it's going to be discontinuous, that means f of 2 would not equal to the limit of the function as x is approaching to 2. Again, f of 2 means I go back to the third piece of the piecewise function and I plug in x to be 2. So b times 2 squared minus a. Again, when I think about the limit, I could think about the left limit, right limit, make them equal, find the limit. But because I know it's going to be discontinuous, I'm going to go straight to the second piece of the piecewise function and write down the fact that f of x is going to be 3x in this case. Again, look what happens. 2 squared is going to be 4. 4 times b minus a. This cannot equal to, again, the first step in limits is you plug it in. 3 times 2, that's going to be 6. Just like the first column, my goal here is to isolate for b, and there's a reason for this. So again, if I isolate for b, I write down 4b cannot equal to, I bring negative a to the right, that's going to be positive a plus 6. The opposite of multiplying by 4 is a divide by 4, and therefore b cannot equal to a divided by 4 plus 3 divided by 2. Now, the goal is find the values of a and b, and by inspection you can tell it's not going to be one answer, it's going to be infinite many answers. Now again, why did I isolate everything in terms of b? Or why did I isolate B, I mean, in terms of A? Think about it like this. B equals to A plus 3. Think of it as y equal to x plus 3. Same idea, right? If you think about this side, y cannot equal to x divided by 4 plus 3 over 2. And again, this will all make sense in a moment. The next step is to find the POI, find the point of intersection so you know what not to write is the final answer. Then we can talk about the values that are above and below, or to the left and to the right of that. So to find the POI, the point of intersection, you make them equal first. So B equals to B. On the left-hand side, A plus 3 equals to A divided by 4 plus 3 divided by 2. Now to solve for A, the opposite of multiplying by 4, or the opposite of dividing by 4, is to multiply everything by 4. So look what happens. I multiply the left-hand side by 4. I multiply the right-hand side by 4. And this will give me 4a plus 12, which equals to a plus 4 divided by 2 is 2. 2 times 3 is going to be 6. When I bring a to the left, 4a minus a is going to be 3a. 6 minus 12 is going to be negative 6. And of course, the opposite of multiplying by negative 6 is to divide by negative 6. So a is going to be, or I should say, let's try again. The opposite of multiplying by 3 is to divide by 3. And I should say a equals to negative 2. See, you can tell I'm doing this live with you with nothing in front of me. So if a equals to negative 2, this means I can solve for b. Now, if I plug it back to here, you can tell b equals to negative 2 plus 3. So b equals to 1. Okay, here comes the graph. And then everything else, ideally, should make sense. So I go back and I graph this. So here we go. The graph looks, roughly speaking, something like this. I'm mapping it out in my mind. I'm beginning with the two graphs, and the POI is going to be roughly there. So I think if I'm doing this right, here are the actual graphs. So first of all, I know one of the graphs, and I call this X and Y. I should really call this A and B. That's kind of the framework. And I know that one of the graphs is going to be B equal to A plus 3, which looks like that. Now, let's go back and add this right there. And in a different color, let's say we use this color, we know the other graph is going to be B, which cannot equal to A divided by 4 plus 3 divided by 2. So that means if you look at the y-intercept, it's going to be at 3 over 2. If you think about the slope, it's going to be 1 divided by 4. So up by 1, right by 4. Or you can go the other way. But roughly speaking, the graph is going to look like that. And again, as expected, the POI is going to be at negative 2 and 1. Now, the hard part's over. Remember, the goal is to solve for A and B. So the two regions that you want to think about is what happens when B is going to be greater than 1. And what happens when B is going to be less than 1. Are you ready? Here we go. If you think about B, again, that's going to be everywhere up here, which is right here. What happens when B is greater than 1? Well, A has to be greater than negative 2. So again, when B is greater than 1, A has to be greater than negative 2. So again, if you think about all the values, that's the area shaded in gray. If I look at the other area, let's go here, which I'll highlight right there. When B is less than 1, then A must be less than negative 2. So again, those are the answers, and just be mindful there are infinite many answers for A and B. I hope this makes sense.